So today we will solve some problems of free body diagram. How to analyze them and how to solve them, I'll tell you today. Let me draw the diagram first. So vertical wall is given. And the roller is there. The weight of the roller is given as 100 Newton. And it is attached with the wall by means of a string, like that. And the angle is given as 50 degree. This is the problem given. 100 Newton is tied to a smooth wall by a string. Find the tension and the reaction from the wall. So we need to find the tension and reaction from the wall. So first we need to draw the free body diagram. We have to do that. We need to separate that thing with the support. Let us draw that ball separately. And here on the center point, this weight will work. And tension is always act towards the hinge or support, and this is the R. So we need to find the value of T and the value of R. So now we have to, what we have to do again in the next step. The next thing we have to do, we have to draw the force, all the forces away from the center. This will help you to analyze the angle more accurately. So the third step, 100 Newton is already away from the center. So 100 Newton. R is not away from the center, so it has to be drawn like that. R, and this was T. Okay. Now, as that angle is 15, so this angle is 15. Okay. So there are two ways to solve this problem. One way to apply the Lami's theorem, and another way to solve to resolve the forces in vertically and horizontally, and making the summation of horizontal forces 0 and vertical forces 0, like that. So firstly we will apply the Lami's theorem, that each force is proportional to the sine of angle between the other two forces. So each force is proportional to sine of angle between the other forces. So firstly we will take the force T. So I can write from Lami's theorem, so T force divided by sine of angle between the other two forces, that is the angle between R and 100 Newton. So that angle is 90 degree, isn't it? Is equal to, let us say, force R. Force R. So angle between 100 Newton and T. So 100 Newton and T means the angle between 100 Newton and T is, so the whole angle is 180 degree. This whole angle is 180 degree. So 180 degree minus 15 degree. 180 minus 15. So the angle is 165. So R by sine 165 degree. Okay. Is equal to 100 divided by sine of angle between other two. So angle between R and T, this angle is 90 degree, so 90 plus 15 degree, so 90, 100, 105 degree. Sine 105 degree. Okay, so that is how the Lami's theorem has been applied. Now at the next step we will solve them. Now how it is being solved. So I will make t by sine 90 degree is equal to 100 by sine 105 degree. So then, so t is equal to, from these two equations, like t by sine 90 degree is equal to 100 by sine 105 degree. So t is equal to 100 by sine 105 to 103. 150 is equal to 103. 103.52 Newton. Okay. And R is equal to
26.8.
26. Yes,
26.8.
26.8. Okay, very good. 26.8 Newton. So these values has been applied by applying the Lami's theorem. Now I am showing you another way to solve these numericals. How it is solved, that we have to resolve the forces vertically and horizontally. Okay. So the R force is already horizontal and 100 Newton force is already vertical. So we don't need to resolve them, but the T force can be resolved into vertical and horizontal components. So I'm taking another color pen to make you understand better. Okay. So now, to the vertical component, you can see this component of T force will be T was 15 degree, and horizontal component will be like that, T and 15 degree. As I have already told you that it does not mean that horizontal force will always be cos and vertical force will always be sine. It is not like that. But the angle, this force is cos 15, and the perpendicular to cos component is always be sine. Now, then if we make the analysis, okay. So as the body in equilibrium, now I have to write here as the body is in, please follow my steps, as the body is in equilibrium. So I can write summation of horizontal forces as 0. So this is the x-axis and this is the y-axis. Okay. So summation of forces as x direction is 0. That means so x forces are R is equal to T sine 15 degree. Is there any horizontal force? No. So two horizontal forces are here only, and summation of forces in the y direction is also 0. So Y direction forces are again 2. So 100 Newton is equal to T cos 15 degree. So from that to value of T is equal to, let me do everything in the calculator. So 100 by 100 divided by 15, 103.52. So the answers are coming out correct. 103.52 Newton. If I put the T value here, so R value will be found. So R is equal to this multiplied by sine 15, 26.7, approximately 26.8. So answers are coming out as same for both the two cases. Okay. So these are the two ways how that problem can be solved. Okay, this is one example. I am taking another example also for you. In the book, there are numerous, several examples are available. You please do them later. Okay, now
सर इस मेथड से
take
तो सर
another.
वैल्यू फोर्स का वैल्यू सर टी का वैल्यू तो 104.16 आ रहा सर.
तो ठीक है, मेरा तो 103 ही निकला है. ठीक है, 103 और 104 are almost same. Your answer is also correct. Okay, that does not matter. Okay, 103 and 104 they are same. Okay, now the next one. There is an inclined plane given. It's very good that you are doing this with me. It's very good. Everybody is doing with me. Okay. And now an inclined plane is given. So this means this hatch line means that plane is fixed. Now the body is there. A body. Let me see the weight. Okay, 150, 1,500 Newton. The body is given, and 1,500 Newton. The weight of the body is given, and the angle is given. Inclination of that plane is 30 degree, and the horizontal force has been applied to the body to keep that body into equilibrium. So angle 30 degree given, 1,500 Newton is the weight of the body. These two things are given, and I need to find the value of that horizontal force F. Okay, to keep that body into equilibrium. Now I need to, at the next step again, I need to draw the free body diagram. So that body has to be separated from the support. Okay, I have drawn that body from the support. Now, maybe at the first step to draw the free body diagram, I cannot draw all the forces away from the center. So in the next stage, you may add one stage also. Newton. I can draw F here. And a reaction force will be there. Here, I am showing at the first diagram itself. So here, a reaction force will act like that. R. Okay, and if that angle is 30 degrees, so then this angle will also become 30 degree, isn't it? Because horizontal and plane 30 degree. So the vertical with the line perpendicular to the plane, or with the line perpendicular to the plane. So that angle will also be 30 degree. Horizontal with the plane 30 degree, and vertical with the line perpendicular to the plane. So both lines are perpendicular here. So that angle also becomes 30 degree. So now here I can draw that L from the center. Like that, so that force is R. So with the vertical, let me write it another color. So with the vertical, this R force is making an angle 30 degree. Okay. So this is the problem given. Now again there are two steps. I am doing the two steps here again to make you understand better. But when you are given this problem in exam, you can apply any of the steps like Lami's theorem or the analysis of the forces. So I will apply Lami's theorem first. And Lami's theorem. So R divided by sine of angle between the other two forces, 90 degree, equals to sine 91. F divided by sine of angle between the other two forces, that means this force, angle between the 1500 and R, so that will be 180 minus 30, 250,
150.
0, yes, and next 1500 divided by sine the angle between these two forces, so 90 plus 30, 420. And again this can be solved easily. So R is equal to 1732. And F, the value of the force to keep the body in equilibrium, coming out as, let me calculate that first. 1500 divided by 920 into 750, 866. 866. Okay, so these are coming out like that. Now the next step will be to resolve the forces. Vertical and horizontal. These are horizontal and vertical already. So I am giving the axis here. This is X and this is Y. So that component is R plus 30. And create another component here opposite to F. That will be R sine 30. Now, analysis part. Here I am doing the analysis. Oof. Again, you have to write as the body is in equilibrium, then F is equal to, by resolving the forces in x direction, equating it to 0, so F is equal to R sin 30 degree and or cos 30 degree equal to 1500. So R is equal to 1732 Newton, and from this equation we can become what? 8. The answers are coming equal in both the cases. So this is how the problems can be solved. Please see them again.